this lesson, we're going to talk about graphing parabolas using vertex form. This is the equation for vertex form. In the equation, the a value will tell you how far the graph is stretched from the parent graph, and the h and k values tell you what the vertex will be. Notice in the equation, the h value is negative, while in the vertex, the h value is positive. That tells you that when you write the x value for the coordinate of the vertex, you're going to have to remember to change its sign. A parent graph is the most basic of a particular type of graph. And in our quadratic function, the parent graph will be y equals x squared. Now this is a simplified version of the parent graph. If I actually write out the equation with all the variables and their values, it'll be y equals 1 times x minus 0 squared plus 0. This is now showing the values of a, h, and k. And notice if you were to simplify that, you would get the x squared back. So that tells me that the vertex in this case will be at 0, 0. Because our a value is 0, our h value is 0, and our k value is also 0. So when we graph that, we'll have a point here at 0, 0. Now we can use a simple table to get some other points in our graph. If I were to use x as 1, x squared will give me 1. So we've got a point here at 1, 1. In the same way, 2 squared gives me 4, so there's a point at 2, 4. And 3 squared gives me 9, so that there's a point at 3, 9. In the same way, negative 1 squared is also positive 1. Negative 2 squared is positive 4. And negative 3 squared is positive 9. So when we have our parent graph and it's not stretched at all, whenever we have to go over 1, we will also go up 1. And when we go over 2, we'll have to go up 4. And when we go over 3, we'll have to go up 9 spaces to get to our next point. Now let's take a look at a graph that's not in vertex form so we can find out how to make it that way. Our steps, first step, put the equation into standard form. Standard form, remember, looks like y equals ax squared plus bx plus c. And our equation that we're given is in standard form, so we don't actually have to do anything for that step. Step 2, we're going to group the x squared and x terms together, these two here, and factor out the a value. Remember, the a value is the coefficient of x squared. So we'll still have our y equals, and we're going to factor out the a value. So a is 2. When we factor it out, we're going to have to open up a set of parentheses and then divide both of those terms by a. 2x squared divided by a is x squared, and negative 12x divided by a is negative 6x. And then we still have that 14 there at the end. So that's step 2. In step 3, we want to figure out how to make the term inside the parentheses into a perfect square trinomial. And in order to do that, we're going to use the formula b divided by 2 squared. When we use the formula, we want our new value of b instead of our original. So we're going to take negative 6 divided by 2 and square the result. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So in step 4, we're going to add the result from our formula inside the parentheses. So we're going to take this 9 value. So we've got y equals 2 times the quantity x squared minus 6x. And we're going to add 9 inside the parentheses with the x squared and negative 6x. The problem is I don't actually want to change the value of the expression on that side of the equation. So I have to figure out what I can do so that I can still add 9 there, but not change the value. So when you add something, but then subtract it, that will keep the value the same. So that's what I'm going to do here. Now it looks like I added 9, but because it's in parentheses with the 2 in front, I actually added 18. I got that by multiplying the number in front of the parentheses, which was the a value. So if I were to distribute the 2, the 9 would then become an 18. So that number 18, I have to also subtract from my 14. That will make it so that my value actually doesn't change on that side of the expression. My last step is to factor the trinomial in the parentheses. So I still have the y equals 2, and this is a perfect square trinomial. The shortcut to factoring perfect square trinomials is you take the square root of the first term, square root of x squared is x, use your first sign, and then take the square root of the last term, which is 3. And that quantity will be squared. Then if I add the 14 and negative 18, I end up with negative 4, and this equation is now in vertex form. I'm going to use this vertex form to graph my equation. So this was my original, y equals negative 2x squared minus 12x plus 14. That was my original equation. And when I put it into vertex form, it ended up being y equals 2 times the quantity x minus 3 squared minus 4. And that is my vertex form. Remember from the equation, y equals a times x minus h squared plus k. When we find our vertex, we have to remember to change the sign. Because in our equation, there's a negative in front of the h, then in our vertex, there's not. So here's our x value for the vertex, but we do, again, have to remember to change its sign. And then our y value gets to keep its sign. So this is going to be our vertex. So there's a point here on our graph, and that, again, will be our vertex. Remember from our parent graph, if we go over one space, we had to go up one space because 1 squared was 1. If we went over 2 spaces, we had to go up 4 spaces because 2 squared is 4. And if we go over 3 spaces, we had to go up 9 spaces because 3 squared is 9. And this is where our a value comes into play, because a is 2. That tells me that all of these y values, I have to multiply by 2 in order to get what this graph actually does. So 1 times 2 is 2, 4 times 2 gives me 8, and 3 times 2 gives me 18. So when I graph this one, if I go over 1 space, I actually have to go up 2 spaces. If I go over 2 spaces, I actually have to go up 8 spaces. And if I go over 3 spaces, I have to go up 18. And this graph actually doesn't go that high, so I'm not going to put this point on there. But that's where it would be if I were to graph it. Remember also your vertex is on the axis of symmetry, so anything on one side of the graph gets reflected on the other side. So there's also going to be a point here, straight across from my original, and there's going to be a point here. So when I connect all those together, I end up with my graph.